So this is quite a famous problem, the sum of 1 over the square numbers. So if we use the residue method, then we have the following formula. So this is our f of n. So f of n is 1 over n squared. And notice we don't sum where n equals 0. Okay. So we have this result. This is equal to minus pi times the residue. So we then look at 1 over n squared. Obviously this only has one pole, which is at n equals 0. So it's a residue of cot pi z times f of z. So it's 1 over z squared, evaluated at 0. So there's two things to do here. One, obviously, evaluate the residue, which will be a pole of order 3, because we've got a pole of order 1 at z equals 0 times a pole of order 2 at z equals 0, so it'd be pole of order 3. The other thing to consider is, how is this thing related to this? Well, hopefully it's fairly clear that if we write out this series, we'll get twice this. So 2s is equal to this. So we could therefore write that this is equal to 2s. And to find the residue of this, it's actually easiest if you have a nice formula sheet which tells you the expansion of cot. So cot of z is equal to 1 over z minus z over 3 plus etc. So so cot pi z therefore is this. And dividing by z squared, I end up with this, and this is pi over 3z. So therefore the residue of this is going to be minus pi over 3. So we've got that 2s is equal to minus pi times minus pi over 3, which means that s is equal to pi squared over 6.